0.5 kg. Is attached to a string of length 2 meters and is whirled in a horizontal circle. If the string can withstand tension 9 newtons, then maximum velocity. Force acting on it, centrifugal force, so which should be equal to 9 newtons. mr omega square is this 0.5, and radius is nothing but length of the string. He is asking only velocity. Okay. So mass is 0.5 half kg, radius is, which is equal to v square is 36, v will be 6 meter per second. Pressure power is equal to rate of work done, ml square t power minus 3. So dimension of t, time, here is next will be surface tension, force per unit length, mt power minus 2, which is minus 2. Next is Planck's constant. E here is c by lambda. ml t power minus 2, lambda is in length, velocity of light. ml t power minus 1. So dimension of time, here is minus 1. So in descending order, so minus, here we have to write descending order means minus 1 is highest. So h Tp, this is descent, minus 1 greater than, minus 2 greater than. So the minimum velocity of a projectile will be at the highest point that we given mu cos theta as 20. So cos 60 with 60 degrees to u will be 40 meter per second. Bomb of 1 kg, mass of bomb 1000 grams. So initially it is projected with 100 meter per second. Velocity after 5 seconds is 100 minus 10 into 5, 50 meter per second. It explodes without applying an external force. So momentum is conserved. Initially it is going upward direction with a speed just before explosion. After explosion, momentum 400 gram moves down, remaining 600 gram with what velocity in which direction we don't know. So 2 zeros, it can say 500J plus 100J is equal to 6V. V here is 600 by 6J. So it moves upward with 100 meter per second. So here ball is dropped from a height. H. The coefficient of restitution is U. The average velocity of the ball from the instant it is dropped till goes to a maximum height. So after first hit, it rises to a height h1. At this point, velocity is v. So v square here is 2gh. After impact, it rises with the ev velocity. The maximum height will be v square by 2g. So that is h is v square by 2g. h1 here is v square h. So average velocity means net displacement. That is h minus h1. h minus v square h into 1 minus h. To reach from A to B, it takes a time. V is equal to gt, that is t equal to b by g. To reach C, that is with u by g, that is cv by g. Total time here is v by g into 1 plus. V here is root 2 gh by this 1 plus. So now here it is h into 1 minus v square by root of 2gh by g of 1 plus c. So here it is root of 1 minus c, which is equal to root of gh by 2, fourth option. The body is projected vertically up with certain velocity. The ratio of velocity projection of velocity of the point in its path. At this point, its velocity v. At this point, its velocity is v1. The ratio of potential energy, let us say it reaches a height h. Potential energy is to kinetic energy of mv1 square. That is 2gh is to v1 square. So what he given is the velocity of projection to velocity at that point is 6 by 25 v square is 36 v1 square. 25 v square is v square plus minus 2gh. So 11 v square equal to 72 gh. So 2gh is to v1 square is 72 by 11. Here it is v square, but we want v1 square. So v1 square is 25 by 36 into v square, 72 by 11 gh. Will trace 36. So v1 square here is 50 gh by 11. So 11 is to 25. So it's body of mass with a velocity collides another body. Something is not given by default. It is elastic collision. Whatever the type of collision, momentum is conserved. So M1 moves with a velocity 10, M2 is at rest. M1 moves with 2, M2 moves with 5 meters per second after collision. So 8 M1 is equal to 5 M2. M1 by M2 is 5 by 8. So a capillary tube of radius r is dipped in a liquid. So surface tension force acts along the circumference is T into 2 pi r, which is equal to the weight So the weight of the liquid inside the capillary tube is this. The potentiometer wire of length 49 meters and 49 meters, 49 ohms, connected in series with a battery of EMF 10 volts, internal resistance 1 ohm, external resistance R. Follow potential along the potentiometer wire, where AB is potentiometer wire. Per 1 meter, potential gradient is given 100 millivolt per meter. So this is 10 power minus 1 volt per meter. Potential difference across AB will be 14. For 1 meter, it is this much, but 49 meters, 49.1, 4.9 volts. So here it is. Effective current will be 10 by 1 plus R plus 49, which implies 50 plus R into I is 10. Here the current in this circuit 4.9 by 49.1 amperes. 50 plus R, 0.1 means 1 by 10. 50 plus R is 100. R here is 50 volts. The student is asked to connect each of EMF 1.5 volts and internal resistance 0.25 ohms. But one cell is wrongly connected. So this effective EMF will be 1.5 into 2, 3 volts. These EMFs get cancelled out. And each has internal resistance 0.25 for cells. This is the effective resistance is this. External net resistance. So the current in the circuit is 1.5 amperes. The speed of the particle remains constant because that is correct, since centripetal force is perpendicular to velocity. Right, four sides but at right angles. So speed will not be affected by this force because force is perpendicular to velocity. Assertion is correct or is false. So initially here you have two radioactive materials having initially have same number of nuclei. After some time, number of nuclei will be e power minus lambda 1t. Other here e power minus lambda 2. So n1 by n2, he given it as 1 by e power minus 10 lambda t by e power minus lambda t is equal 9 lambda t will be fourth option. The current 1 ampere is flows vertically downwards. Then magnetic field will be here vertically upwards. that is vertically downwards. It moves in a circular loops. Magnetic field lines are circles. So suppose here magnetic field, consider Earth like this. So here it is geometrical north, magnetic north, magnetic south. That means geometric north will be this side, geometric south. It is magnetic north, magnetic south. So the field lines will be like this. So at the point here, north, east, west. So here it is magnetic field lines due to Earth and magnetic field lines due to uh, magnet, that is due to the current carrying wire. They get cancelled out in the east direction because net magnetic field is zero. So that at what distance means mu naught I by 4 pi d is equal to 5 into 10 power minus 5. Mu naught for 10 power minus 7, uh, 1 ampere current. D is equal to 5 into 10 power minus 5. So D will be 1 by 5. By it is 2 pi d. So it is 2 by 5, which is 0.4 meters from the wire. The mass and radius of a metal disc M and R, it is moving with a velocity. It's a disk M. It's moving with a velocity V on a plane. It stops after climbing up an inclined angle at a height h. Then initially, when it is at this point, is mgh. Initially, what energy it has since it is rolling. Total energy is due to translation as well as rotation. Total kinetic energy. This moment of inertia is this. A square by r square is half. GH is equal to half v square 1 plus half. So what he is asking is velocity. V square here is 4gh by 3. V will be 2 root gh by 3. A circular coil of area 12 meters square and number of turns like this you have 30 placed in a magnetic field with its plane perpendicular to it, rotated about its own angular velocity. So here it is rotating, but flux lines will be, there is no change in the flux. So EMF is minus d5 by dt. So